All right. Our last new lesson, or new material for the term. Yeah, tomorrow's our review day, test on Monday, review the rest of the week next week for a final on Thursday. So we are in section 5.4 today, covering the application problems, and I'm gonna rely or take advantage of say the share feature here today to just look at our homework problems, really, or at least my versions of them. Let's see, make sure I let everybody in. And you might even, well, these will be my versions, right, of those homework problems in 5.4. And I believe you are now able to see my problems, my screen. And as you know, the way this works, you have the same kind of problem, but the numbers in your problem might be different. Now, so if we, if we kind of look through these, think about them a bit, then you could even have your own versions of them open and possibly kind of mirror what we might be going over. But anyway, if you take some good notes here, get the idea of the different kinds of problems we're asking you to do in this section, and hopefully we come up with good approaches for them. So number one here is really just like the one that I kind of finished up with yesterday and suggested I think that it worked well as a elimination problem. Now you notice here, eventually it says solve the system that you have written. So for the most part, I think in this section, you're going to get to choose, or have to choose, put it that way, which technique you want to use. I would just say don't plan on using graphing unless it's a requested graphing problem. Like I said, too hard to be sure you're coming up with the right answer by graphing. All right, so there's that first sentence, just like the one I did at the end of class yesterday. I think the sum of two numbers is 88. And the difference of those two numbers is what, 58. I have to get close enough so I can see my own computer here. So what are the two numbers? And just like I must have read this problem, tried to set up yesterday, if we let X be the larger number, then when we do the difference, we get X minus Y, right? Y the smaller number. So write an equation that expresses the information in the sentence, the sum of two numbers is 88. So they're really trying to walk you through it. There's that first, excuse me, well, the first sentence. Can you write an equation for that first sentence? Now, I would encourage you maybe to, call this question one, 5.4 number one, and write down your equations for yourself as we go. And I'm gonna, click on the answer here eventually, and we'll see if you agreed with what we're looking for. Now this one, I'm hoping sounds pretty straightforward. So the sum of those two numbers being 88, there's what we're looking for. X plus Y equals 88. Okay, and the next part, the difference, right? The difference of the two numbers is 58. Of course, I start talking and loosen up the frog in my throat. But there we go. Did you come up with the equation for that second one? The difference, right? So there's the equation that you're supposed to try to come up with for that second condition, the second sentence. So those two together are your system. Solve the system. Of course, I would expect you to do this on the side or on your own paper, scratch paper. Show your work, but you see how those equations I think would work very well for the elimination method, right? If you were to add those two equations together right now, the y's are going to cancel out, and you're going to get something like 2x equals whatever that big number would be. What is it, 146 or 156, something like that. Do the math. But That's the idea there, all right? Now, your own problem should look just like this, only probably slightly different numbers, but sort of the same kinds of things we're trying to get you to write here, okay? Now, I'm not going to try to finish solving that. If that makes sense, you know, you have to be able to set up your own and then work with the numbers that you have. So I'm ready to go on, but if somebody really has a question about that process from here on out, let me know, okay? So if that's okay, I'm going to scroll up, and here comes number 2, all right? And it's sort of similar in that we're just working with 2 different numbers that we're trying to find. You know, call the first one X, call the second one Y. I think it maybe doesn't, yeah, it does tell us that again. But the relationships are a little more, you might say, complicated, right? And so what does it say? The sum of 2 times the first. So here we're going to do some multiplying, right? 2 times X plus 3 times the Y, right? 3 times the second. So the sum is 144. So it's a very similar to just add them together, but no, we're going to multiply and add them together. Now the second one, second sentence there, a little bit different. The rearrange, it's the form of this second equation won't be quite what we expect and might have to do a little rearranging, right? The difference between, so we're going to do a subtraction, right? The difference between 7 times the first, right? And negative 57. Oh, 7 times the first minus a negative 57 is, there's your equal sign, 6 times the second. Oh, so the other variables on the other side on this one. That's kind of what that's all about. Now, if you got the first sentence, right? 2 times the first plus 3 times the second. And there's the total they asked for. That second one, the difference. So you're going to subtract and be careful even on your own problem. Looks like in mine, subtracting a negative, right? So here we go, 7 times the first minus, yep, minus, and they just did minus, minus and called it plus. They didn't write it out as minus, minus, minus a negative, okay? Hope you're clear on that. And it's supposed to equal 6 times the second. So there's that second equation. Now, just looking at the form of the 2 equations there, I still think it would be rather messy to say, try to use the substitution method. The first equation, I think you could divide by the 2 to solve for X or divide by the 3 to solve for Y, and you might get whole numbers. But if you were just to rearrange the second equation, right? Move the 57, move the 6Y, then we'd have 2 of them that you could use the elimination method for, all right? So just pointing out the weirdness about that second equation and how you might decide to deal with it, right? Put it in the X plus Y kind of shape equals the negative 57 in that case, right? If those concepts make sense, right? You have to write your own equation. Your multiples might be slightly different, but probably very similar construction for that second equation for your own problems, okay? And then I would recommend the elimination method. You know, just off the top of my head, I'm thinking maybe the Y's would be easy to get the same number. In my problem anyway. I'm rolling up to number 3, okay? And I'm gonna blow my nose, excuse me. This, I think, is a perimeter problem. Like way back when. Excuse me. Yeah, our old favorites, the perimeter problem. You might even just draw yourself a rectangle, you know, a visual, right? So it is, mine says the room is 1.4 times as long as it is wide. And its perimeter is 28 meters. Total perimeter, right? Total perimeter is 28 meters. This one, they're not walking you through it step by step. They're just asking for the length and the width. You have to remember your perimeter formula, that total value of 28 in my problem, right? 28 is twice the width plus twice the length, right? And then we have a relationship between the length and the width. And usually it's the length equals some version of the width, right? The length is 1.4 times the width, I think is what this problem is implying, right? So there's your second equation. The length equals 1.4 W is what I would come up with. Hope that makes sense. That makes, this perimeter kind of problem is one that has been working well for us as a substitution problem, even before we knew what we were calling it substitution, right? If the length equals 1.4 W, then you can plug that in instead of the L in the basic perimeter formula. Make sure that you still do 2 times the L, right? 2 times the 1.4 W. But that'll get you that one equation with just a bunch of W's in it that you got to solve for. Yeah, you've got some decimals, but you get to use some calculators. That's not too tough, huh? I hope. So kind of talking through, all right? And if something gets really confusing, interrupt me and we'll stop and I'll pull up the whiteboard. Here's another one, all right? That is another perimeter problem. This one, rather than saying the length is a multiple of the width, it's saying it's a certain number added, right? The rectangular room is 2 meters longer. So for our, still our basic perimeter formula, what's the total? In my problem, the total says 20. But then the length equals is your second equation, right? The length equals the width, and mine says 2 meters longer. So I'd say width plus 2 would be my second equation. Again, the perimeter problems tend to work very well for the substitution method. Plug that expression in for L. Okay. The next one. All right, marbles. All right, yeah, who counts their marbles this way? A bag filled with green and blue marbles. There are 49 marbles in the bag. The construction here is very similar to like the perimeter problem, I think. If there are 9 more green than blue, find the number of green and the number of blue marbles. So first of all, you might have to think about, oh, well, what are we looking for? What am I calling my variables? The variables are the quantity of blue and the quantity of green. You might say B equals the number of blue marbles and G equals the number of green marbles, just to maybe think of something other than X and Y, right? So that first sentence says that quantity total is 49. So that's simply adding them together, right? The number of greens plus the number of blues equals 49. X plus Y or B plus G. The second one is the second condition is very similar to what we'd have to do with the length and width for the perimeter problems, right? But here, be careful. Maybe write it out both ways and think about it yourself. Is it that the blue equals green plus 9, or is it the green equals blue plus 9? It says there are 9 more green than blue. So the green is being compared to the blue. That's kind of why you got to analyze that, right? The green is the blue plus something, right? There are 9 more greens than blue. So starting from the blue, if I add blue plus 9, that equals the green. So you want to be careful about that kind of sentence and just, don't rush to write it backwards, you might say. Otherwise you get your blue and your green numbers reversed. Again, if you having trouble coming up with those 2 equations, let me know. Like I said, I would say B plus G equals 49, and then what is it here? Green equals blue plus 9 for my 2. And again, that looks like a good substitution problem. I get that little bit of crud down there every morning and I have to cough it up. Sorry. All right, number 6. This is one I was alluding to at the very end of class yesterday. And let's see, yeah, this one's going to ask you to solve. So here it starts out as a multiple choice with 5 choices. And this problem referring to a quantity of adult and child tickets that were sold, right? There were children plus adults and a total number of tickets sold. And then the second equation for this kind of problem usually then relates to how much money was made from selling that quantity. And so that you have to take the quantity, like if X is adult tickets, well, 8 times X is the amount of money you make selling adult tickets, right? And 3.50, right? 3.5 times Y is the amount of money you make selling children's tickets. And then they tell us a total amount of revenue there. So looking at those equations below, one of those equations, usually I say the first one is the easy one where you just add the 2 different things together and you get the total number sold. Not the amount, not the money, but just the quantity. So you got to kind of look through that list and say, which one shows me, you know, if I just add them together, I'm going to get the total number of tickets. And, you know, so what you'd want to do is say, oh, look at the first one you're subtracting. It can't be that one. The second one, it adds up to the 4,025. That's not what that number stands for. The third one, okay, it adds up to 700. It could be that. The fourth one, it adds up to 700. It could be that. And the fifth one's just totally weird. Where'd that come from, right? So then you have to look, okay, so I'm looking at equations 3 and 4. Which one then for the second equation has the right cost number associated with, say, X? Let's see, did they tell you? Yeah, X is adults and Y is children. So which one has the $8 on the X? You know, so you got to do a little multiple choice evaluating there. Once you decide which pair of those equations is the right system, then it says solve it. Now, this might not be too tough as a substitution problem, right? Could solve that first equation for X or Y, but also the elimination. Like I could multiply, say, the first equation by -8 or something like that. And substitution, I mean, elimination might work just fine for this kind also. So you really kind of, which way do you like to go? And then just be, you know, be sure you're clear the X's are the adults and the Y's the children for this particular problem. The next one, same kind of problem, I believe. And now, same kind, yeah. Only this time they're talking about coins, gold and silver coins, X's and Y's, and the value of a gold coin and the value of a silver coin, like the cost of adult versus children's tickets. This one didn't even ask you to solve it, right? Just do the multiple choice and figure out which pair of equations fits the situation they gave you. It's going to be the same kind of analysis that we just talked through on the previous one. All right. Shall I slow down or keep moving or doing any good for you? I hope. Here's one there. I think it's the same kind of problem, but now they don't give you the multiple choice. Now that you've had 2 tries at this, you've got to come up with the equations yourself. And then it just asks for the number of dimes and quarters. So you're completely writing these equations on your own worksheet, and then solve and come up with the answers. So 26 coins, dimes and quarters. And they're counting on you to know that a dime is worth 10 cents and a quarter is worth 25 cents, right? So there's a total number of coins. That's like the X plus Y, right? And then the total value, right? 10 cents times every dime plus 25 cents times every quarter has to add up. And they nicely put it all in. They didn't mix up units on you. It's all cents, no decimal points. Okay. So again, this will be a situation where you get 2 of those equations, much like the one before, as far as that shape with the X's and Y's on the left equaling a total. And you get to decide, is substitution or elimination going to work best for you for that. And number 9, I think we're changing gears now, for the forms anyway. Different calling plans. I often use something like this as an early example, whether it's calling plans or, you know, a sales job plus commission or something. These are 2 different situations that I would claim create y equals mx plus b shape equations, right? The total is some fixed amount plus a variable amount, right? So 2 different calling plans. Mine has a fee of 15, there's that fixed amount, plus 3 cents per minute. There's your slope, right? Based on the number of minutes, there's a slope number. So you might say y equals 0.03x plus 15. I would say something like that for mine, right? The second equation is the same kind of shape. So we have 2 equations solved for y, right? Y equals this one or y equals that one. That was that situation we went over a couple times yesterday or the day before, where you can kind of set them equal to each other and find the number of minutes, right? They didn't even ask you what the total would be. Just find the x, find the number of minutes where the costs would be the same. So if you solve it for the x, this one doesn't ask you for the y. Yeah, it happens in applications sometimes like that. But 2 y equals mx plus b, both solved for y already. Makes substitution, I think, work pretty well there. Same kind of question. Is this the last one? It is. Well, look at that. All right, 10 questions for your homework. Same kind of question. 2 pay options, but I mean same kind of question in that the form of the equations will again be y equals mx plus b shape equations, right? So a base salary plus 10% of your sales. Be careful, change that 10% to a decimal, right? 0.10 times the amount of sale. Your amount of sale maybe be your x value, right? So there's your slope, is 10, plus 10% of everything you sell. And that second one, you know, base salary, a higher base salary, but less commission, right? Again, be careful, convert that 3% to the correct decimal value to plug into your equation. But again, they're both, you might say, solved for y, set them equal to each other, and just reading the specific question, in order for the 2 to have the same total salary, you would need to sell at least. Yes, so just solving for the x value again. Now, that got you through the application homework, my talking you through. If you would like, we could spend a little more time on something here. If you want to let me know, I'll stop moving things. If you're very comfortable with all that, you know, we could say that's it. We come back and review tomorrow. But put me to work. What should we do from here? Somebody would like to chime in. That's okay. Should I stop the share and do something on the board? Or I'm going to stop the share anyway. Here goes. And I'm sitting here. Yeah, I got to sit today. Did that help enough for you to get through those? Yeah, I see some nods. Thank you.
It helped me for sure. I appreciate you going through it one by one. So thank you.
Good, good. If you don't mind, who was that? That just.
That was Dana. That was me.
Oh, hi.
Yeah.
Yeah, I don't see everybody all at once, and who did suddenly unmute. Thank you. Now I don't really want to shortchange you, but that's kind of all I really had in mind for today, was kind of talking through like that, all those different problems. And of course, you'll want to get them done before Monday and Monday's tests. But if you really got stuck on your versions of them, you can always send me a question, please, and I'll try to write you back a good answer, point you in the right direction. Well, unless you tell me let's do something else, I think I'm going to call it a day. All right? Are you all right with that today?
I am for myself. Yeah, I don't know about everybody else. But.
Right, right. Yeah. So, okay, I see folks starting to log out already. Well, good luck with that then. Give them a try. Tomorrow I'll probably bring that one of the review worksheets that's in Mom. That optional paper review is something that I had put together for in class when we were in a classroom. I'll probably work through those as a selection of, or a sampling of the different kinds of problems that you could expect on a test, and you know, a little of everything, right? A little of everything. So we'll work through that as a review tomorrow, a little of everything. Okay, well, you have a good day then, and let me know if you run into trouble, and I'll try to help.
Thank you. Have a
You're
good
welcome.
day.
See you later. I know there's almost like a joke trying to end a Zoom. End a Zoom. You know, you hang up. No, you hang up. No. See ya.